Hello everyone, welcome to week 7 of Codivate Python class. We have an interesting series of topics for today. We're going to learn about the math module, the random module, and we're also going to go over some string methods. Alright, so before we get to the math module, let's just go over some of the inbuilt math functions in Python. We have the abs function, which returns the absolute value or distance from 0 of the inputted number. In our example here, when we print the abs function here, called on -3, that's our parameter, our output, if we were to print this, is just 3. And the reason is because -3, you can think of it as being 3 units away from 0. So another useful inbuilt function in Python is the max and min functions. So the max function can be called on a list or tuple, and it will return the largest value in the list. The min will do the same thing, but it will give us the smallest value in the list or tuple. So for example, we have our num list here, has a bunch of values, 3, 5, -1, 6, and 2. If we were to create a variable called maximum and assign to that max, and then inside the parameters for max we are going to put our num list, then it will store the value of the maximum number in here. We could do the same thing for minimum, make a variable called minimum, assign it the min function called on the list, and we'll get the minimum number. If we print the maximum and the minimum, you'll see that this is correct. We print 6, which is the largest number in this list, and -1, which is the smallest number in this list. An interesting thing about this is that it will also work on strings. If we do max and we have a list of strings, it will give us the longest string. If you do min, it will give us the shortest string. This one is another useful inbuilt method. It is called sum, and it returns the sum of the items in a list or tuple. For example, if I were to print the sum function called on this list of numbers here, 1, 2, 3, 4, our output is 10. We can confirm this. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So that's what we have here. And this is kind of useful. Let's say we want to find the average of a list. The first thing we have to do is take the sum and then divide by the number of numbers. So if we want to find the average of a list, we could just do the sum of the list divided by the length of the list. Alright, now that we went over some basic inbuilt math methods, let's go over the actual math module. So a module in Python is basically, you can think of it as a file containing a bunch of definitions and statements that we can import into another file of code. And once we import it, we can use functions from that module. So this is the syntax here. Before we use the math module, we have to import it. The way we import it is just write this line right here. Import, and then math. Make sure it's all lowercase, and this should be at the top of your code. And then once we have this in a line in our code, we can use the math module later on. So how would we use the math module? We use this dot, and we say math, which is the name of the module we imported, dot. Then we can call any method and input the correct parameters. There's no actual method called method, and it doesn't have a parameter called parameter. This is just a representation of the syntax and format of how we would use a math class. It'll make a little bit more sense when we get into the examples. So in each of these examples I'm going to show you, I'm just going to assume that math has been imported above this code. We don't want to write import math every single time when we show the demonstrations. Just assume that there's an import math above here that allows us to use these methods. So this first line here doesn't really have anything to do with the math module. We're just creating a variable called num and assigning it the value of 2.01. This is a float. So what we have here is an actual use of a math method. Math.ceil will round a num up to the next int. So in this case, we use math. That's just our syntax for any math method. Use our dot. We use the name of the method, which is ceil. And then we are inputting the parameter, which in this case is a number. And that number is being stored in this variable called num. So once we call the math.ceil method on 2.01 and print that result, we get 3. So what exactly does this do? Math.ceil will round up whatever this inputted num is up to the next int. So if I have 2.5, it would be rounded up to 3. If I have 2.99999, it would be rounded up to 3. Even if I have 2.000001, it will be rounded up to 3. It won't round to the nearest integer. Another method which does the opposite of math.ceil is math.floor. It will round the num down to the previous int. So if we have 2.01 and we use math.floor on the number, our output is 2. If we had 2.99999, it would still print 2 if we were to call this method. Alright, so this is another interesting method in the math module. It's the GCD method. So the greatest common divisor is what GCD stands for. And the greatest common divisor, you may have heard of it as the greatest common factor, is basically the largest factor shared by two numbers. So if we want to take the GCD of 24 and 32, we could do it using this math method. I'm creating a variable called GCD2432 that will store the GCD. And I'm assigning to it this math method that will give me a GCD, math.gcd, all lowercase, and then inside the parentheses, this time I have to put in 2 parameters because you can find the greatest common divisor of 2 numbers. So I put in the 2 numbers I want to find the greatest common divisor of 24 and 32. After this method call returns a value, it will be stored to this variable. Once that variable is printed, we see this output of 8. So let's just confirm that Python did the math correctly, and we could do that by writing out all the factors of 24, all the factors of 32. So we see a couple common factors. We have common factor of 1, common factor of 2, common factor of 4, but we want the greatest common factor. So the greatest common factor, the largest number that's in both of these lists, is 8. And that's the result that's given by our Python method. So we know that this works correctly. Okay, so here's another math module method. If you want to find the square root of a number, we can use the sqrt function. And we don't have to type out squareroot. We could just do sqrt. And this is the math method used to find the square root. So if you're not sure what exactly a square root is, if you want to find the square root of a number, we just have to find what number multiplied by itself gives us this number. So the square root of 49 is 7.0. That is because if we do 7 times 7, we get 49. One thing to notice here is that we took this method call and stored it to a variable and printed it. And when we did that, we got our result as a decimal. And the reason is, when we do math.sqrt, we take the square root and we store it as a float, which is a decimal number. So this is just another example of using the math.sqrt function. We're taking the square root of 2, and it gives us this very long decimal, 1.414, and so on. Same setup here, we're assigning it to a variable and printing the variable. But the thing is, if we wanted to get the integer square root, for example, we didn't want this 0.0 here, then we have to use a different method. We could use the isqrt method. And you could basically think of this as I for integer square root. And what this will do is this will take whatever result we get by doing the regular square root function, and then it will round down. This is a bit more easier than another way we could do this using our programming knowledge. We could cast this entire thing as an int using the int and then the parentheses. But instead of doing that, we could just type one letter here, and that would be done by the math method for us. So these are just some ways to find the square root of a number, and also if you want to round it to the nearest integer, it's easier to use ISQRT rather than to cast this entire result as an int. Alright, so this slide we don't need to go over too much in depth, but if we want to use mathematical constants in Python for calculations, we can access them like this. So you may have heard of pi. It is the ratio used in circles. So if you want to access that, all we have to do is math dot and then pi. That will give us the constant. We could store this to a variable called pi and then use it in calculations later on. Once again, just as a reminder, we need to import the math module above so that we can actually use all of these. So one thing you'll notice is that we don't need parentheses, and that's just because we're getting a value here. These other constants, we don't need to get in depth about like the actual meanings, but just know that you can access some constants if you learn about them later on in math. You can access them using math dot and then the name of the constant. Alright, so that takes care of the math module. The other module we're going to learn about today is the random module. So if we want to generate random numbers in Python, this is the module we have to use. So the syntax for the random module is the same as what we learned with the math module. We say the word import at the top of our code, and then after that we type random because we want to import the random module. In our code, as we are using it, we have the same syntax as we had for the math module, random dot and then method and parameter. Once again, there's no actual method called method. This is just a representation of how to use the random module. Let's take a look at some actual methods so we can understand this module. If we want to generate a random integer in a certain range, we can use the randint function. So what we're doing here is doing random dot randint, and we type in two parameters separated by a comma. So the first parameter will be the starting of the range, and the second parameter will be the ending of the range. So let's say our starting and ending parts of the range were a and b. This would give us a random integer from a to b, and it would be possible that we get a and b as a random integer. It's not going to be exclusive. So in our case, we are creating a variable to test this method out. We're just going to call it n. And to that, we are assigning random dot randint, and then we have our parentheses to input the parameters 1 to 10. So what this is doing is it's picking a random number from 1 to 10 and assigning it to this variable n. Every time I run this code, I might get a different result. It is possible I get the same result, but it's not always going to be that way. So one time I ran it, I got the result of 1. Another time I run it, I get 7. Another time 3. Another time 10. One thing you'll notice is that unlike other things in Python, this thing actually includes the beginning and ending indices. So 1 is a possibility for the random, and 10 is also a possibility for the random. So this is another useful method in the random module. It is called choice. So we can choose a random letter from a string or a list using this choice method. And the parameter would just be the list or the string. We can assign the randomly chosen letter in a variable and then print the result. For example, I have a variable called randLetter, and I'm assigning to it random.choice and then a string inside. What this will do is it will pick a random letter within this string, and it will assign that to randLetter. So this is a bit more easier than generating a random index and then using that index to get something from the string or a list. So it's easier to just use the random.choice method if you want to randomly pick something from let's say, a string or a list. Once again, it's implied that we have the import random above this code, which allows this to work. And every time we run this code, we could get a different letter. For example, the first time I ran it, I got the letter R. Another time I ran it, got the letter D. We could also do this with a list. We make a variable called coin and assign it a list. And this list contains two values, heads and tails. I'm making another variable called side and assigning to it random.choice coin. So this will do is it will go to the coin list and pick a random item from this, either heads or tails. And then once we have that result, it will assign it to side, and on our next line we print that out. Sometimes we could get heads and sometimes we could get tails. So you'll notice is that random is useful for simulating real life events. For example, we simulated a coin flip here. Alright, this one is a really interesting method. It's called the shuffle method, and we can apply it on a list or an iterable like this. For example, we have a deck here, and we're assigning to that a list of all these values. We have A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, and K. This is kind of simulating a card deck, or just one suit in a card deck, and then this is how we would use the random method to shuffle the deck. And keep in mind, when we shuffle the deck, it will change this list. It won't make a copy of it. So we do random dot shuffle, and then in our parameter, we input the list that we want to shuffle. As soon as we do this, and we print this same deck variable, you'll see that it's changed, and everything's in a different order now. If we run this code a lot of times, we might get different orders each time. But one thing to note, once again, is that we are changing this list. We are not making a copy and changing that. We are actually changing this list. It's kind of similar to the sort methods that we looked at with lists. Alright, so that takes care of the random module, and our last topic of the day is strings. You may be thinking, we already learned strings, but we need to learn a lot more. So we just learned what they are, just basic understanding, but now we're going to learn how to manipulate them and apply methods on them. So if you want to access characters in a string, it's the same as how we do it for a list. We use the string name, or the variable, followed by square brackets, which contain the index. Once again, indexing starts at 0. So in this string, I'm assigning it hello, and the indices and their corresponding letters are shown here. At the 0th index, we have H. At the first index, we have E. At the second index, we have L. At the third index, we also have L. And at the fourth index, we have O. So this is an example. If I wanted to access something, I would use the string name, square brackets, and then the index. I'm accessing a certain letter in here. Based on what we learned about lists, what do you think this will print? You can pause the video, give it a go, and then play it when you're ready to check your answer. Okay, so this one is pretty simple. We just look at the index. We could go back to our table and see, okay, at this index, the string has a value of E. So we print this out, and our result is E. One thing to note about strings is that they are immutable. Strings, unlike lists, cannot be changed once they're created. So this concept of immutability can be illustrated in this code segment. We have a string called lang, and we're assigning to it cat. And then we try to change that string. We try to go to this string, we're accessing the first index, or the first letter using the 0th index, and we're assigning to that H. You may think that if we had a list, it would change the first item to whatever this is. But since this is a string, it won't change the C to an H. If we were to try to print this, then we get an error. And this type error tells us that the string object does not support item assignment, which is what we're doing in this line. We cannot change an index in a string the same way that we do with lists because strings are immutable. So slicing strings has the same syntax that we have for lists. We specify a start index, then we have a colon, and we specify an end index. So we start at the start index and end at end index -1, same thing that we had for lists. So this is just an example. Based on what we learned with lists, what do you think this will print? You can pause the video and give it a go. Alright, so this prints LLO. The one thing that may be confusing here is that instead of using a variable name for the list, we directly, for the string, we directly just type the string. And then we have our slice specified here. And we are assigning that to a different variable. We're not using the variable for this string, we're using the variable for the actual slice. Now, if we go and check the indices, we start at index 2, 0, 1, 2. So we start at this L. That'll be the first letter in our slice. And we have to end at end index -1. So 5 minus 1 is 4, we have to end at 4. 0, 1, 2, 3, 4. So O is going to be our last one. We have LLO, and that's what appears when we print this slice. One way that is useful to visualize string indices when we're slicing is to draw these dots in between all of the letters or characters inside the string. So once we have those dots, each of those dots can represent an index. So for example, in our example that we had here, from the dot at index 2, 0, 1, 2, to the dot at index 5, which is here, and we were to take that slice, the only letters that get included are L, L, and O. So this is just a way, if you're having trouble with remembering that it's end index -1, you can just draw these dots, one before the start of the string, one after the string, and one in between each of the letters, and then just go from 0 and start writing down numbers for each of the dots, and you can use those to imagine slices. So this is another thing that we could do with lists that we can also do with strings. If we leave one of the parameters blank, they will just have default values. If we leave the start index blank, then it will just default to the beginning of the list, of the string, which would be 0. So you can, if this is empty, you can just imagine a 0 here. So in our example here, you'll notice that we print the first two letters. We start at 0, which is here, and end at 2 minus 1, which is right here, 0, 1. You can see HE. Another thing that you'll notice is that it will just print the first two letters. So if you see a slice like this, and let's say if there was 3 here, then you could just understand that it's the first 3 letters instead of just looking at indices. There's a lot of ways to understand this concept of string slicing, and you could just think of it the way that it works for you. Now here, we can also leave the end index blank and specify a start index. It will use the start index, but assume that the end index is just the end of the list, or the length of the string, sorry. Keep saying list. Yeah. So for example here, if we were to do 2, we would start at 0, 1, 2, which is the L, and we would end at the end of the string. So we will include L, L, and O. Now let's get some practice with string slicing. You can pause the video, write down what you think will print for each of these, and once you're ready, we'll go over the solutions. Okay, let's go over the solutions. For the first one, our start index is 4, and our end index is 5 minus 1, which is also 4. So this slice will just give us the letter at the fourth index. So let's find that. 0, 1, 2, 3, 4. So that gives us the letter O. Well, this is a way to print O, but there are faster ways of doing it. We could just use an index. We could just use the fourth index instead of actually making it a slice. But to practice, this is just a good example. The next one, our start index is 7. 0, 1, 2, 3, 4, 5, 6, 7. One thing you'll notice there is that the space does count as an index. So even though you may not see it, Python will take the string literally and think that there's also a character there. So 0, 1, 2, 3, 4, 5, 6, 7 gives us a start index at the beginning of this class. So we start at C, and the end index is just going to be the end of the string, so we print class. And for this last one, we know that our end index would be 6 minus 1, which is 5, so let's do that. 0, 1, 2, 3, 4, 5. So our last letter is N, and we start at the beginning of the string, so we go from the beginning of the string to N, which gives us Python. Alright, let's look at some string methods. These are just some methods we could use to get information about strings. We can use the len method to get the length or number of letters in a string. For example, we have our string called address here. We have a variable called a, and we're assigning it the length at the address. If we were to print this out, print a, then our output would be 11, because there's 11 characters in here. You can count it out just to confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One thing you'll notice is that I didn't start counting at 0 is because I'm not using the index. I'm not trying to find any index or anything. I'm just trying to find how many characters are here, and that's the length. Another method is string.count and then another string inside the parameters. This will just tell us how many times this string 2 appears in this main string. So our main string here is Main Street, and we're assigning it to this variable address. If you want to count the number of keys, it will give us 2. You can see that there's only 2 keys in here. If you were to print B out, you'll get the result of 2. So another one is string.upper. This will just give us an uppercase copy of the string. All of the letters will be uppercase. If we were to make a variable C and assign it address.upper, you'll see, and we were to print that variable out, you can see that we have Main Street in all caps. Similarly, we have the string.lower method that will give us a lowercase copy of the string. We start off with a variable called D and assign it address.lower, so we'll get Main Street without any capitalized letters. Our last method is string.index string 2. This will give us the index of the first occurrence of string 2 inside string 1. In our example, we are creating a variable called E, and we are assigning it address, which is Main Street, dot index of E. What we're doing here is finding the first index of E in address and assigning that to E. Let's find the first index of E. 0, 1, 2, 3, 4, 5, 6, 7, 8. And that is what is stored to E. Once we print that out, our result is correctly printed out as 8. Alright, so we have another string method. It's the sorted method. It's very similar to the sorted method for lists. It will just give us a list of the letters in the string in alphabetical order. So we have the string here, listen, and it will give us all of its letters in a list in alphabetical order. So we have E, I, L, N, S, T. So this is our last string method for the day. It's called the split method. So what it does is it makes a list of the words in a string that are separated by a space. So here we have a string called sentence, and we're assigning this sentence has a few words. if we were to print sentence.split, we would get a list. And this list basically has all these words, all the words in the sentence as items, and we can tell that it found those based on where the space was. So if we don't specify anything in this split, it will just split up the sentence into a list based on where it has the spaces. We can also assign this sentence.split to a list variable, and then we could manipulate it from there. If we wanted to split it based on something besides a space, we would have to specify the parameter inside the parentheses. For example, here, I have a sentence here that is A, \nb, \nc, \nd, \ne. And if I wanted to get just A, B, C, D, E in a list, I could use the split method and split it based on where the \n is. So what this will do is, instead of using just a blank space to determine where to split the list or the string, it will split it based on \n. Now, see that we have A, B, C, D, E in our list. So these are the exercises for the day. You can pause the video. The exercises for today are pretty simple, but we also have a challenge exercise we're going to get to, so that will be a little bit more challenging. So you can pause the video, attempt to do these, and then we'll go over it together. Alright, I'm assuming you had a go at it. The first exercise is to write a program that simulates a dice roll. Prints a random int from 1 to 6. Let's go over the solution. So, in order to do this, this one's a pretty simple one. All we need is 2 lines. We have to import random, so we can actually use the random module. Then we print random.randint 1, 6. And the reason why this simulates a dice roll is because on a 6-sided dice, all we can have are integers from 1 to 6, and our random.randint with these parameters will give us a random int from 1 to 6. If we were to run this program a few times, you can see we get a few different numbers every time we run it. Alright, exercise 2. Write a program to find the longest string in this list. So this one is pretty simple. We just have to make our list here, string list, and assign it all the values that were given. We just basically have to copy this one into our code. And what we are coding here is just printing the maximum item in the list in a nicely formatted way. We are printing the longest string in the list is, and then max of the string list. So we can use the max method like this, not only to find the largest number in a list, but also to find the longest string in a list. It correctly finds that the longest string in the list is strawberry. One thing you will notice is that we're using the plus sign and we don't cast this as a string. You may be wondering, why is that? Wouldn't it cause a type error? And the reason it doesn't is because strawberry is a string. We can concatenate a string to a string using the plus sign. But if we had a list of, let's say, numbers, and we wanted to say the longest number in the largest number in the list is, then we would have to use a string casting around our max. Yeah, so this is the challenge exercises for the week. We have to write a program that asks the user to input 2 numbers and returns their least common multiple. We also have to continue to ask until the user input is valid. One thing to note is that the math module does not have any inbuilt LCM method. So we have to use this formula here to calculate the actual LCM. The LCM of 2 numbers times the GCD of those same 2 numbers is equal to the product of the 2 numbers. So if we simplify this formula, we get that the LCM is equal to A times B, which are the 2 numbers, divided by their GCD. You can pause the video and come back to it when you're ready to go over the solution. Alright, I'm assuming you had a go at it. So for this, the first thing we're going to do is import the math module so we can use the GCD method. We're going to need that because that's what as how we're going to calculate the LCM. So our general format for continuing to ask until something is valid is to use the while true in conjunction with the try and except. So in our while true, the first thing we're going to do is ask the user to input two numbers. So num1 is going to be assigned whatever they input in the first line, and num2 is going to be assigned whatever they input in the second line. We're going to try to create a variable called a and assign to that the first number cast as an int, because remember, the input will always be seen as a string. And if you want to do mathematical operations on it, we have to cast it as an int. So we create two variables for that to cast them as ints. Now we make a variable called LCM, and we assign it this formula that we did here. A times B divided by math.gcd a comma b. Remember, for the method, we need to use the name of the module, dot, and then the method name. Once we have that, we're going to cast LCM as a string so we can print it out nicely. And once we do all of that, we print LCM of the first number. And notice here we're not using the A and B because we want to use the string. And here, when we're taking it directly from the input, it's still a string. Same thing for num2. So LCM of the first number that they entered and the second number that they entered is, and we have our LCM cast as a string. So that's where the result will be stored, and we can print that out. So if this happened successfully, we were able to cast both of them as integers, then we would break. And we were able to actually do all of these calculations and print the result, we would break. However, if there was an error, for example, the user enters something like banana for a number, then we would have an except, and we would print, please enter actual numbers. So in the case that this doesn't work, we would go to the except, and since it's a loop, we'll go back to the top of the loop and ask the user for two numbers. Let's take a look at how this code would play out if we ran it. The user is asked to enter a number, 9, and they're asked to enter another number. Let's say we type in a string here, 50. Well, a word here instead of a number, 50. Then, let's go back to our code. It would try to cast these as ints. It would be able to cast the first one as an int, but it wouldn't be able to cast the second one as an int. And as soon as this causes an error, it would say, okay, I'm going to stop and I'm going to go to the except. It goes to the except and it says, please enter actual numbers. Goes back to the top of the loop and asks for numbers. This time I enter dog and cat. It gets an error as soon as I try to cast dog to an int. And then I go to the except, and once again we get please enter actual numbers. The last time I do it, enter a number, I entered 12 and 18. And this time, we're able to execute all of this code correctly and it prints. The LCM of 12 and 18 is 36. And this makes sense because the smallest number that has both of these as factors is indeed 36. So that takes care of our lesson for this week. If you have any questions, you can feel free to reach out on the Discord or at the email. And stay tuned for next week's lesson.